Hello, everyone. This video is looking at predicting products for double replacement reactions where a precipitate forms. A precipitate is a solid substance that comes out of solution. Now, in order for us to know whether or not a precipitate will form, we have to use the solubility rules. To understand those solubility rules, we need to understand the words soluble and insoluble. So if a substance is soluble, that means it will dissolve in solution, forming an aqueous solution. If the substance is insoluble, that means it will form that solid that we call a precipitate. Okay? So taking a look at our first example, we have calcium chloride reacting with potassium carbonate, and we need to figure out what our products will be. So with any double replacement reaction, the calcium is going to connect with carbonate, okay? That's going to be calcium's new partner, if you will, the cation, anion, and potassium is going to connect with chloride. Now, one mistake that I notice that's made when writing formulas for the products is that students will bring across the same subscript. So if you see a 2 after the potassium here, when you're writing the formula for potassium chloride, you'll put that 2 down. But that's not what you do. You have to look at the charges for the new compound and then balance those charges. For example, potassium has a charge of 1 plus, chloride's charge is -1. So if I balance those charges, if I look at the ratio, I only need 1 potassium ion for every 1 chloride ion. So it's going to be KCl in terms of my formula. And I'm going to do the same thing for calcium and carbonate. Calcium's 2 plus, carbonate's -2, and I just need 1 of each. Okay, so now I need to see if either of these will form a solid. So if you have your solubility rules, let's look at them. On the rules that we're using in my class, you'll see on number 2A, all chlorides are soluble, okay, except silver chloride, mercury 1 chloride, and lead 2 chloride, which are insoluble. And this is potassium chloride, so it's soluble, which means it is AQ. All right. And then the next one is carbonate. And so to find carbonate, I need to go down to number 5. And it says phosphates, sulfites, and carbonates are insoluble, except ammonium and group 1A compounds. Well, calcium is from group 2A, so that means this calcium carbonate is insoluble and it forms a solid. Okay? Let's look at another example. We have barium chloride reacting with potassium phosphate. Okay, barium chloride reacting with potassium phosphate, and we need to see what our products will be. So barium is going to now connect with phosphate. Potassium is going to connect with chloride. All right. So if I look at my products, potassium and chloride, potassium's 1 positive, chloride is 1 negative. So I just need 1 of each. Excuse me. And then barium is 2 plus, phosphate is 3 negative. So I'm going to need 3 bariums for every 2 phosphate ions to balance out those charges. Then I go back to my solubility rules. I don't need to look that far because potassium chloride is the same product that I have up here, and it is aqueous, so that's AQ. Now I need to look at the phosphates, and if you remember, phosphate is in the same group that I had carbonate. It was phosphate, sulfite, and carbonate, and it is insoluble because barium is a group 2A element, so that is a solid. Okay. We have one more example here where we have lead to nitrate and it reacts with potassium hydroxide. It seems we have potassium a lot in these examples. So the potassium is going to connect with nitrate. Lead is going to connect with the hydroxide. Okay. All right, and so our products are going to be lead to hydroxide. So it's going to be Pb with a charge of 2 plus. Hydroxide is OH negative, so I need 2 of them. And then KNO3, because K is positive 1, NO3 is negative 1. Okay, checking out your solubility rules. Okay, checking out your solubility rules, we see that hydroxides are number 7. Normally, hydroxides are insoluble, all right, except when they're connected to ammonium, group 1A, and group 2A from calcium down. When I look at this, Pb is not ammonium. It's not in groups 1A or 2A, so this is a solid. And then NO3 is number 3 on our solubility rules list. And see, chlorates, nitrates, and acetates are soluble, so that is AQ. All right. And so that is how we go through figuring out the precipitate or the solid from a double replacement reaction where we have to predict the products. Make sure you have your solubility rules that you can use to go through this. If you have those rules, it'll make it a whole lot easier. If you have any questions, you can comment below. If you're one of my personal students, you can always just send me an email and I'll get back with you. Thank you for watching.